This is a quadratic formula, and I know that because it is a degree 2, meaning that the highest exponent that I see on the variable x is a 2. So I know it's going to create a parabola shape, and it's going to open upwards because the a value is positive. So really quick, I'm going to go off to the side. I'm going to identify A, B, and C. And you don't have to do that if you can just look at the equation and you already can identify those without writing them out. So the first step is I want to know what is the axis of symmetry. Some teachers call it line of symmetry, others call it axis of symmetry. It means the same thing. It cuts the parabola in half. Here's the equation you'll always use. So I'm going to substitute the following variables in for B and A. And then half of 7, if you're unsure, you can use a calculator. Half of 7 is 3.5. So I'm going to find where x is 3.5. And I'm going to make a dotted line going through the x-axis, running vertical at 3.5. If you were asked to identify the line of symmetry or the axis of symmetry, it would be x equals 3.5. Once again, if you were asked to identify what is the equation for the line of symmetry, or it may be worded axis of symmetry, for this problem it would be x equals 3.5. Now with this value, to go on to the next part, we want to identify where's the vertex. The vertex will lie somewhere along this line, and I know that the parabola is going to open upward. So I take this value and I substitute it into the original equation wherever you see an x. And I'm going to change the g of x into a y. Grab your calculator and let the calculator do the hard work. Make sure to use parentheses wherever you're substituting a number. Negative 8.25 is the number I achieved. So 1, 2, 3, 4, 5, 6, 7, 8. 6, 7, 8. So 8.25, here's approximation. So if somebody said really quick, what is the line of symmetry? You would write x equals 3.5. Coordinates for the vertex. Along the line 3.5 and at a y value of negative 8.25 would be the vertex. Do not round that. You're going to approximate on the graph, but do not round it when you give the official number.
What don't we round?
Like, don't round this to a negative 8.3 when you actually write it down. All right, now the toughest part for most students is identifying the x-intercepts. We always want to first check, can we factor this? Because if we can factor it, life is going to be easy. So I'm going to use the bottoms-up approach. 1 times 4 is 4. I want to see if it's possible to find two numbers that multiply to achieve the number positive 4 and combine to give you a negative 7. 1 and 4 and 2 and 2 don't somehow multiply to give you positive 4 and combine to give you a negative 7, right? If you can't factor, you need to go back to the quadratic formula, and you have to have this memorized. So for A, B, and C, I'm going to substitute from the original equation the values for A, B, and C. I'm going to plug this into the calculator, the discriminant, to get an answer. Make sure that the b is in parentheses. So the discriminant is 33. Yesterday we learned that if the discriminant is positive, you'll have 2 real roots. If the discriminant was equal to 0, you'd have 1. If this number would have been negative, which we won't have today, but if this number would be negative, you'd have 2 complex roots, which are the same as having no real roots, no x-intercepts. Okay, so this is going to be tied to our x-intercepts. I'm just going to write x-intercepts here. We're going to come back to this. This is the actual value for x. Now, in order for me to graph that on this graph, I need to be able to approximate on the graph. So we're going to plug it in together. It seems like a simple process, but often students make a mistake with the keystroke. Okay, let's start with 7 plus, and to get the square root, you're going to get the blue key, go straight down in the same column until you find the square root, type in 33 and press enter. Now divide by 2, and I'm going to approximate on the graph. So approximately 6.4. So I'm going to find 6.4 approximately. 1, 2, 3, 4, 5, 6, 7. So 6.4 right about here. I'm going to do the same thing, and this time I'm going to subtract. 7, subtract the square root of 33. Make sure to press enter. Divided by 2, press enter. And I'm going to round again to the nearest tenth, which is 0.6. So here's 1, 0, and 1, and 0.6 is right about here. When you graph this in standard form, you need to identify key features of the graph. So I have the line of symmetry, I have the vertex, I have the x-intercepts, and one advantage of being in standard form is that the y-intercept shows up right away. So 4 is the y-intercept. So go up 4, 1, 2, 3, 4, and identify it on the graph. Now, here's the trick. Hopefully you understand that symmetry takes a parabola and it directly cuts it in half, right? So watch really quick. If I measure the distance from this point to the line of symmetry, I could go the same distance over here and make the next point. So here is 1, 2, 3.5. So this is 3.5. Well, if I add an additional 3.5, what's 3.5 and 3.5? 7. So along this level, I'm going to go over 7. 1, 2, 3, 4, 5, 6, 7, and go up 3.5. When you're connecting the points and drawing the parabola, make sure you don't have a sharp point at the bottom. Make sure you have arrows heading up. Okay, we've done all the work. Now we just need to analyze things. So if you were asked to identify the vertex would be 3.5 and negative 8.25. There is no rounding. If you were asked to identify the line of symmetry or the axis of symmetry, it is an equation, x equals 3.5. Okay, now listen to this. This is a little tricky. All eyes up here, please. X-intercepts. I want the exact x-intercepts when I ask, so don't give me an approximation. Remember how we use this to approximate? This is the exact x value. So x-intercepts, there's 2 of them at these points, but I don't want the rounded answer. So the x-intercepts would be, one of them is adding, and the other one is subtracting. These are the exact x-intercepts. Remember, when you have an x-intercept, y is equal to 0. And when you have a y-intercept, x is equal to 0. Bless you. So our y-intercept is 4, and again, that's one of the advantages of standard form, as you can see it right from the equation. 0, 4 is your y-intercept. And we are going to do 5 more things to make sure you understand this. And these are all things you've learned from Unit 1. The first one is domain, so let's look at this. Remember that for quadratic functions, meaning the parabola opens up or the parabola opens down, the domain will always be negative infinity to positive. The range, this goes down as far as, we're not going to approximate, this goes down as far as negative 8.25, and there's no limit how high it goes. The smaller number is written first, larger second. So there's our domain and range. If you are asked to identify where it increases, remember from left to right, you're going down in this position. This is our turning point we learned about yesterday, also known as a vertex, and then it goes from going down, it turns and goes up. So decreasing is in this portion. At this arrow, it's being pulled to the left while it's being pulled upward, and it's being pulled to the right while it's being pulled upward. So when we describe increasing and decreasing intervals, it's in terms of their x values. So most of you understand this is decreasing, but how do you write it? It's coming from the left. There's no limit how far it goes to the left. So decreasing is negative infinity, and it continues to decrease until it gets to this turning point. The x value at this turning point is 3.5. Increasing and decreasing have parentheses. Increasing, it starts to increase when the x value is 3.5. There's no limit how far it continues to go to the right for increasing. And the very last one. Yesterday we spoke about end behavior again, and we said that for degree 2 functions, which would be quadratics, both ends either both go up or they both go down. So as you analyze this, as you look to the left, which direction is it going? Up. And as you look to the right, it is also going up.